Stanford University.
All right, well, welcome to lecture number 16 of CS 193P at Stanford. Today we're going to continue kind of our grab bag of features to go through. And I'm driving what I'm showing here a little bit by what I'm seeing in your final project proposals. I'm trying to cover features that a lot of you are doing, and I'm going to do the same thing on Thursday. So today, I have one more thing I wanted to show you about view animation, a little different way to do animation than I demoed last time. Then I'm going to show what UI segmented control. It seemed to me that a lot of your user interfaces could benefit from this particular it's kind of like a button, this radio button kind of thing. So I'll show you that. I'm going to go over core motion. Quite a few of you are planning to try and use core motion in your applications. And then I'll do alerts, two different kind of alerts, and NS timer, which may or may not be of some usefulness to you, and also another method which allows you to perform a method on an object after delay and allows you to cancel it in the middle, and you'll see why that might be useful, especially if you're thinking you want a timer but you're not really sure how you want to do something. I'll go over both of those. All right, so let me talk about the view animation first. So view animation. So I showed you last time how you can change the properties of a view and then animate it, so like it's alpha or whatever. So this is another view animation method. There's actually a pair of them here called transition from view or transition with views. And what this has to do with is transitioning changes in the view hierarchy. Now, what I'm going to do today is I'm going to talk about a lot of stuff, and then at the end, or maybe in the middle, and then also at the end, I'll do a little demo. And so I actually have a great demo that I can show you how to do this, which is the shutter bug with the maps. Because, you know, we click that button to show the map, and it just appears. But really, we'd like a nice thing where it animates, it flips over or curls up or something. And so hopefully, a demo will be worth 1,000 words. And the transition between the two views that's going to be animated, either flipping or curling or whatever, and you've seen this on the iPhone, this kind of animation where one view goes away and one comes in, is controlled by the options. And you can either do it by adding and removing it from the view hierarchy, which the one transition from view to view will do, or you can do it with hidden, which is what I did in the Shutterbug map, right? I had both of them in the view hierarchy, and I was hiding one and unhiding the other one. And so you can do it either way. And there's an option called View Animation Option Show Hide Transition Views, and that determines whether it'll do the hide. Or if you do transition with view, the bottom one, you can do the hiding and adding and removing subview yourself. Okay, the top one does that for you. The bottom one, you get to do it yourself. But otherwise, you can see it looks quite a bit the same. You know, it has an animation block where you say what you're going to do, and a completion block, etc. So hopefully we'll have time to demo that. All right, so the main thing here I wanted to talk about is core motion. So core motion is an API to access any motion sensing hardware on your device. And the primary motion sensing hardware things that come with these devices is an accelerometer, which almost all the devices have, if not all the devices. Excuse me. And that didn't sound good. And a gyro, which only the newer ones have. iPhone 4 and the new iPod Touch have a gyro. Okay? So how do you get at this stuff? It's similar to what we saw with core location. There's a class CM Motion Manager, all right? And you create one of these motion managers, and then we're going to use it to get information about what's happening with the motion of our hardware. And you're only allowed to have one CM Motion Manager in your app, so you're not around allocating and knitting a whole bunch of these and having multiple objects getting information. So I'm actually in the demo, I'm going to show you a little bit about how do you manage a resource when you only get to have one. Okay, what's a kind of a good best practice or coding convention for doing that? So I'm going to show that in the demo. So how do you use this thing? So you have this core motion manager, and you have one of two different mechanisms for using it. One is you check to see what hardware is available, especially to see if it has a gyro, if you're going to try and use that. And then you just start the sampling going and you poll the motion manager for the current state of the accelerometer of the gyro. Okay, so that's kind of a polling model. And again, this is very analogous to what core location does for location sensing. But there's another way to do it, which is you check to see what hardware is available. Then you set the rate at which you want to be notified about changes in the device's, how it's moving. And then you register a block that will get called every time, that rate happens. So the latter one is usually what people are doing, but there are certain applications where you want to poll, but usually you're going to do this block thing. So first, let's talk about that in both cases, this thing of checking the availability of the hardware. Very, very simple. You have this property, it's read-only, it's a bool, and it's accelerometer available, gyro available, and then also a thing called device motion available. Okay? Now, device motion is something we're going to talk about in a couple of slides. It's essentially a combination of accelerometer and gyro. Okay? So you can check to see with this simple method whether the hardware you want is available. So if you're just going to start the thing going and poll, you call this thing start accelerometer updates or start gyro updates, and then it'll start collecting that information, and then you can find out whether it's doing that with this accelerometer active or gyro active. And then when you're done collecting samples, though, you want to make sure you stop it, okay? Because you don't want the OS unnecessarily collecting all this data that you might be polling on when you're not actually doing anything. Same with core location, right? You don't want the thing trying to look for GPS satellites when you're not actually caring about where you are right now in your program. Same thing here. You don't want to be, finding out what's going on with the accelerometer and gyro when that's happening. So that's how you kind of start. You check to see if it's available, you start it, and you stop it. And in between, you do this polling. And the polling, very straightforward. If you want to poll the accelerometer data, you call this method accelerometer data on the motion manager. And it returns this object called a CM accelerometer data object, which really just has one property called acceleration. And acceleration is a struct that has the acceleration, raw acceleration, in the x, y, and z. So x is laterally, y is top to bottom, and z is, if your device is sitting down, z is down, okay? And it's measured in g. So if you set the thing on a perfectly flat surface and all else being equal, you would get z is 1, right? 1g, acceleration due to gravity, and the other ones would be 0. Now, the reality is you set it, the surface is not perfectly even, you'll get z is 0.98, and the other two, you're getting a little bit of acceleration due to gravity. And then, of course, if you start shaking it, you jerk it to the left, you're going to get a big acceleration in the x or up, down, or whatever. So you can get these big spikes because it's kind of an instantaneous measure of acceleration. Sorry, and because of that, you want to be careful to use an appropriate filter on this raw data, high-pass filter, a low-pass filter. And you can look in the documentation to see what kind of applications, what one kind of filter. But just understand you're going to get this very spiky, instantaneous acceleration of the device in all these directions, and that the raw data includes the acceleration due to gravity. Okay, so you have to factor that in as well. So now we're talking about polling for raw acceleration data. The gyro is similar. It's a little different struct, or a little different data return, which is rotation rate. And rotation rate is a struct of x, y, and z. And it's going to tell you the rotation rate, okay, in radians per second in that axis, right? So the x-axis would be rotation this way, y-axis rotation this way, and then z is kind of like yaw, right? Rotation this way. It's right-hand rule. Does everyone know what that is? That's, if you put your right hand like this, the rotation around here is going to be a vector in this direction, okay? This is positive, right? And this is the positive direction is what that means. So device motion is an intelligent combination of the two. All right, so device motion is not just a struct that has all that information in it. It's an intelligent combination. So what do I mean about that? So when you're polling device motion, you actually get two different properties for acceleration. The acceleration due to gravity and the user's acceleration. separated from the gravity. Okay? Now you can understand if you have a gyro, you can much more easily detect the difference in the acceleration that's coming from gravity versus the acceleration from the user's movement, because you can really see the user's movement in the gyro. So you get better acceleration data here, a lot better, because it's separated from gravity if you have a gyro and the accelerator. And then the rotation data is also better. Okay? So in the rotation rate you got from looking at the gyro's raw data, there's a bias in there. I don't really want to spend the time today to go into the details of why that is, but you can imagine that the gyro is an electronic device, and it doesn't just sit there reading 0 when you're not moving and then it starts perfectly responding as you move it. It has a certain bias, a resting voltage. But again, if you know where gravity is pointing and you have accelerometer, there is math, complex math, not super complex, but there's math that will help get that take that bias out. So now you get the rotation rate, but it's really cleaned up, it has no bias in it. And so you also, in addition to getting the kind of cleaned up, unbiased raw data, you also can get the attitude of the device. Okay, so I'm holding the device, and it has a certain attitude in space. Okay, now the attitude can be represented multiple ways, matrix of numbers, etc. But probably the easiest way is using this CM attitude object, which has roll, pitch, and yaw. So I don't know if you guys know those words, but roll is essentially how, if I'm holding the device flat, here I have a device right here actually. So if I'm holding this device flat, right, then roll is like this, right, rolling side to side, and pitch. Imagine I'm a little airplane here, right? So I'm pitching up, pitching down, my nose is up and down, or I'm rolling. And then yawing is like this. Okay, so like if I have an axis that goes straight down through here, and I'm turning this way, that's yaw. Okay, so you can get roll, pitch, and yaw from your device, which is pretty awesome. Now you only get that if you have both the accelerometer and the gyro data, and that's what this device motion business is all about. So no matter which one of these things you're doing, you can poll, as I showed in the previous slides, or you can use blocks. Okay? So the way the blocks work, for example, for accelerometer data, you just say start accelerometer updates to queue, and you give it an operation queue. I'll talk about that in a second. With handler, and then the handler is a block. Okay? And the block takes as an argument the accelerometer data sample that you just got, and also an NS error, which has errors you can look up. So what's this NS operation queue business? All this handling of the information from an accelerometer or from the gyro happens in a thread. Okay, it happens in a separate thread. It doesn't happen in the main thread. We don't want the main thread being constantly updated or blocked or whatever. We're doing some kind of processing of this data, so it starts in another thread. And you might say, well, why doesn't that first argument just take a dispatch queue under bar T, which it could have, but in this operation queue, you can kind of think of as a little more of an object-oriented dispatch under bar Q, under bar T. And if you're really just creating a queue just to handle these things, you can just alloc init a queue, and it'll create one. One thing you want to be careful to do is auto-release that queue. Once you pass it off to here, it'll get retained, so you don't have to worry about that. But that's what you're going to do most of the time, okay, is just alloc init a queue, auto-release it, pass it on here. And that just specifies the thread that this handler is going to be repeatedly called in as the updates happen. And same thing for gyro and device motion data. You just get the other objects instead sent to you, okay? So this is the primary way you're going to do this. You're just going to work off a thread, and it's just going to call this block every time it has data for you. So here's the rate at which that block is going to get called, right? Depends on which kind of thing you're sampling, accelerometer data, gyro data, device motion update. You just set that time interval, how many seconds between times your block is called. I said you can't have multiple motion managers, but you can register multiple blocks. Okay, so you are allowed to call start, getting accelerometer updates with this handler. You can call it more than once, so you can have multiple handlers going. That's perfectly allowed. And so let's do a demo of this. before we go do the other stuff, what I'm going to do is go back to our label mover and add some accelerometer fun to it. So here's our label mover that we had before. I'll run it really quick just to remind ourselves what it does. It just puts a label up here. We click, we can move around, we can swipe, we can, I said I didn't do this, but I'm doing it pretty fast here, and change the label. So that's what it does. So what we're going to do with the accelerometer is I'm going to make it so that it uses the acceleration due to gravity to move the label. So as I tilt my device, that label is going to kind of slide towards gravity, where gravity vector is, okay? Up and down. So that's what we're going to do. And I'm going to do it using the handler, installing the handler mechanism that is, again, most appropriate to this particular way. All right, so how am I going to do that? So here's my label mover code. Remember, it's very simple. I had this view did load. Here's where we do those animations. I have the tap gesture, so when I click, I go around. I have swipe for changing the label contents. Here's my delegate callback for my Asker view controller. So what I'm going to do here for core motion is I'm just going to change view did appear, and I'm going to call super, and then I'm going to call this method, I'll call it start drifting. Okay, I'm going to pass my label to it. And so this method, start drifting, is going to register this handler with the core motion manager and start this thing drifting in the direction of gravity. Okay. Now, one thing I have to remember to do for performance considerations here is when view did disappear, I want to make sure that I stop asking for acceleration events, okay? And we'll talk about how I'm going to do that in a second. Because I don't want, once my view goes off screen, which in this app it never does, but I always want to build view controllers, can be used in different contexts. So whenever this view controller's view goes off screen, I want it to stop asking for accelerometer data, right? Because I'm not using it anymore. Okay, so let's do this start drifting here. Start drifting, and it takes a UI label. Probably all these things that I'm passing this label around probably could be taking views or could just use my label. But all right, so how are we going to do this? Well, I'm just going to go straight to the cut to the chase here. First, I'm going to assume that I have a property called motion manager to give me a motion manager. I'm going to implement that in a second. In fact, let's go ahead and implement that first so we can see how that works. So here's a case where I've got motion manager, and I said I'm only allowed to have one of these motion managers in my app. So how do I share it? I don't want to really have global variables. Probably my app delegate's a good place to put it, but I don't want to import my app delegate in my label mover view controller, because I might take my label mover view controller and move it to another app someday, and it has a different app delegate. Okay, so here's kind of I don't know if it's best practice, but a good practice way to do this, which is I'm going to have an instance method here called motion manager. Oops, let's go ahead and clean this couple things over here. Okay, so first I have to import core motion. Okay, let me close this up so we get some of this happening here. Okay, so how am I going to get this global CM motion manager that I want? And what I'm going to do is I am going to put it in my app delegate, but I'm going to use introspection to see if my app delegate can provide me a motion manager, and if not, I'm just going to return nil. And then if I'm picked up and put into another app that can't provide a motion manager in its app delegate, I just won't do motion. Okay? I'll still do all the other things I do, clicking and spinning and all those things, but I won't be doing motion. Okay? So that's kind of the design context here. So I'm going to say app delegate equals UI application shared application delegate. So I'm getting the delegate of application. This is all fine so far. I haven't had to import the application delegate. And I'm just going to say if the app delegate responds to selector motion manager, okay, so if it can provide me a motion manager, then I'm going to say that motion manager equals app delegate motion manager. Okay, and then I'm just going to return motion manager. Okay, so by using introspection here, I've made it so I don't have to import my app delegate. And so if the app delegate's there, it's going to work. If not, it's not going to work. One thing, if I do it this way, I got to make sure that whatever code uses this motion manager method inside label mover view controller responds and works if it returns nil. Okay, so now I have to go over to my app delegate. So here's my app delegate over here. And so this app delegate is going to provide a motion manager. It's going to be a property. Go in here, CM motion manager. And let's also import core motion here. And then in the delegate, I'm just going to implement that method, the getter, because it's a read only. And what I'm going to do is say if I haven't created it, let's lazily create it, because maybe no one wants this in my app. Like init and return the motion manager. Okay, so everyone understand what I did there to try and make my label mover view controller be somewhat portable, but still have this global shared resource, which is the one motion manager I'm allowed to create. So now I can go back up here. I'm actually going to move it down here to keep from getting a warning. And clean up my spacing. Okay, so now let's go and type the actual motion manager method we want, which is start accelerometer updates to Q. And again, I'm just going to say ns operation Q alloc init auto release. Okay, so I'm just creating a queue here. I'm only going to start this thing drifting in view will appear. I'm not going to be restarting it over and over, or things like that. So I don't need to keep this queue around or anything. And then here's the handler. And remember, the handler takes a CM acceleration data, and it also takes an NS error. Okay, so this is just a block. And turn. Okay, so this is the block of code that's going to be executed here. So all this is going to do, this block is going to do, is it's going to take the label's current frame, it's going to move it in whatever direction gravity is pointing here. I'm only going to do the X and Y. Obviously, I'm not going to make it so that it does something when I flip up. Right? So it's going to be left and right. And then it's going to change the frame of the label to the new location. Now, one thing we have to be careful here is when we set the frame of a label, that's making a UIKit call. So we got to do that in the main thread. Okay? So I'm actually going to do this whole thing in the main thread. But you have to understand that this handler is not being executed in the main thread. It's being executed in this thread right here. Okay? So how do I do something back in the main thread? Dispatch async dispatch underbar get main queue, oops, a block. Okay, that's in any thread. That's how we can dispatch back to our main thread. So let's do that. So here's the implementation of this thing. I'm going to grab the label frame. Okay, label is passed in as an argument here, and of course I can use it inside both this block and inside this block. I'm going to say label frame dot origin dot x plus equals data dot acceleration dot x. So data dot acceleration dot x is the acceleration in the lateral direction in g. So moving it by, even if I had tilted it all the way, that would only be moving it one tick per time interval that this thing is reporting, which we haven't set. And I really want to move a little more than that, so I'm going to create a constant up here. I'm going to call it motion scale. And we can adjust this to kind of give the scale we want. I'm going to start at 5. 5 seems like a reasonable thing. So if I tilt it all the way up, it's going to move this label by 5 pixels or 5 points. Does that make sense? Right? Acceleration of gravity. And I'm rarely going to have it tilted all the way up, so this should probably be about right. One thing I'm also going to do is I'm going to make sure that if I tilt it and it hits an edge, that it doesn't fly right off this view, because then I might not be able to find it. Okay, it might be floating out in outer space somewhere off to the left or whatever. So I'm going to put a little if in here. I'm going to say if CG rect, if it does not contain the rec, I'm going to basically say if my views bounds does not contain the label frame. That's what I'm going to say, yeah. So in other words, if this would make me slip off, then let's go ahead and set our label frame's origin back to what it was before. Okay, so I basically undo that previous line of code if this thing slipped outside the rectangle. So I'm going to do the same thing for the other direction. Actually, I'm going to do minus equals. Does everyone understand why I need to do minus equals for the y direction? That's because y starts at 0 at the top and moves down, whereas x starts on the left and over. So I want it to basically be in the opposite direction to where the gravity is pulling. Dot y times motion scale. Same thing here. In fact, I can just copy and paste this. And we'll set. Notice I'm allowing y and x to be separately set. Even if one hits the edge, the other one will continue to work. And then, so we just set our labels frame to be this new label frame. And that's all we need to do. Now, the other thing to do is the motion manager accelerometer. What is it? I wish this would help me. Accelerometer update interval. Well, I don't remember what it is, but we can look it up. Anyway, I'm going to go quickly here because I got a lot to other demo. But I'm not going to set the interval here. We'll see what the default interval is. I believe the default interval, I want to say it's maybe 100 hertz, which is pretty often, right? So it's going to call my block once every 100th of a second. If that's too fast and our thing is zooming up, then we'll change it. But unfortunately, it's not helping me here, and I can't remember the thing here. But, what do we got here? Oh, I know what it is. Sorry. Accelerometer data. There we go. And what else? Yeah. Origin label frame label dot bounds. Sorry. Okay. So this should start our thing drifting. And now let's just do one thing, which is the stopping. So how do we stop it? And I'm going to do that by saying self.motion manager stop accelerometer update. Oh, thank you. To stop them. Okay? So that way I make sure that they're stopped when view did disappear. And we still have one error, which is, big important error here. Okay, so I've been accessing core motion here, and I imported it. That's all fine. But there's one really important thing I have to do, which is I need to tell Xcode that I want to use the core motion framework. Okay, so you do that by going here to frameworks. You see it. Currently we're using UIKit, Foundation, and Core Graphics. So I'm going to right-click and say Add Existing Framework. Okay, so don't forget this part. If you're using Core Motion or any Core Audio or any of these other frameworks that aren't part of UIKit or Foundation. So I hit Existing Frameworks, and you can see there's a big long list of frameworks here. And so I'm just going to go down here and pick Core Motion and say Add, and then Build, and it shrinks. Now, I'm going to run this. It's not going to work because here we are in the simulator, and so the acceleration is 0. And so now what we're going to do is we're going to hook this up. All right, so I have an iPod Touch here, old style iPod Touch. And so I'm just going to go up here to this and say that I want to run it on the device instead of in the debugger, in the simulator, right? So I'm not going to run it in the simulator here. I'm going to run this on the device. So I'm going to hit Build. let's go ahead and show you what's happening over here. Okay, so here it is. It's now loading this application into my iPod Touch, and you can see it's already started drifting. Okay, so if I tilt up, you can see it's doing that way. If I tilt this way, I can make it tilt faster. Oops, I have a little problem, a little bug there. Okay, and this is still working, right? Our clicking on things is still working. And also our swipe will still work. So we can say here, CS193E, oops, CS103. Okay, this is 103. So you can see I have a little bug here, right? If it's not, I didn't do a very good job of if I go outside the side here. That's really not what I want. So let's go fix that real quick. Huh, labeled, oh, I see. This is bounds, this needs to be frame. Because it's the frame we want to set. Okay, and then, actually I'm going to do this before we switch so we can see it happening over there. I'm just going to hit build and run. For those of you who haven't run things on the device. So you see here it stops it. It's loading it now, loading it over, and starting it up. It's still attached to it in the debugger, so you can go and debug things over here. So now hopefully, yes, see now it's working. When I tilt, stops over here. Notice that when I click, the animation keeps up with the acceleration too. You see? So it's doing both at the same time, which is kind of cool piece of the way view animation work. Okay? Everybody got it? All right. So that's that demo. Let me, while I'm here, I'm going to show you the, I wanted to show you that view animation really quick in a Shutterbug before I go on to do the other stuff. So let's do that. So we're going to quit this, go do Shutterbug map. So doing that view animation is basically one line of code, which is kind of nice. So here's where we're toggling the map. Let me run it real quick, remind you what happens here. So here's our things here, and we click map and see how it just instantly switches over. So we're going to make it so that it flips over. Does a little animation, which is much nicer and looks much more it's for the user much more grounding to have that thing flipping over than this instant change. So all we need to do that is add this transition. So we just say UI view transition with view, and I'm going to, since I'm already doing the hidden stuff right here, I'm already doing it myself. I'm not going to use transition from view to view. I'm going to use transition with view, which says transition these subviews of this other view. And the view that I'm going to be transitioning in is self.view, where I've got these two map view and table view subviews. I'm going to do it in about 0.75 seconds. That seems to be a pretty good flip time. The only option I'm going to use is UI view animation option transition flip, and let's do from left. You can flip it from the left or from the right. There's also curl up and down, things like that. And then here is our animations, and we'll put the completion block at the end. Paste. And let's go ahead and make this nice indentation. And we don't need a completion block, so I'm just going to say nil there. And that's it. Okay, so one line of code as promised. Let's see if this works. All right, so we have this, right? And our map flips. Okay? So you can play with the speed of an animation like that, or whether you want to curl up versus doing this flip kind of thing. But that's how you do that transition. I notice a lot of you are planning to kind of do that sort of thing in your UI, so that's how you do it. All right? Okay, back to our keynote. Here. Any questions about any of that? About core motion? Okay, yeah, question. Oh, so the question is, can I do the thing with the block with core location? And the answer is no. Core location does not support that API. at least not to my knowledge. They might have been something they added recently, but last I checked, they did not have that. So we went over core location last time. The API I showed you, to the best of my knowledge, is the API you have to use to that. Core Motion uses this kind of block API, which is kind of cool. And maybe I think blocks are new in iOS 4.0. You're going to see them creeping into more and more APIs. And in fact, I'm going to do a little demo a little later, and it's going to be kind of obvious, wow, this would be really nice if you could use blocks to do this too. But they haven't put it in absolutely everywhere. When you're building an API like iOS, you've got to be careful. You can't just willy-nilly start throwing things in there. You've got to make sure that it works, and it works in ways that might not be anticipated by most people. So you have to be careful. Yeah.
Were you asking more about including the core motion in the app delegate? That trick?
Oh, I'm sorry. So he's clarifying the question. So the question is, should I do my core location manager in the app delegate like I've done the core motion one? Yeah, that would be absolutely fine. That would be a very reasonable way to think about doing that. Okay, so now some other grab bag things. What I'm going to do is I'm going to go through all these slides, and then at the end I'll just demo as many of these as we can get to with the time allowed. So UI segmented control. So a segmented control, I have a slide problem here, so I have to go all the way to the end to show you what it looks like. There it is. So segmented control kind of looks like a button, but it can have multiple segments. Okay, so this one only has 2 segments, a first segment and a second segment, but you could have 3 or 4 even, or 5 segments, starting to be kind of at the limit of what makes sense for UI segmented control. And it's a radio button, so you click on one, it deselects the other. Okay, and the way to create it, very simple. You alloc and init it with an array of items. The items are either strings, like in this case, first and second, or they can also be images. All right, so you can have an array of images in there as well. So you can see there in the second part, UI segmented control alloc init with items. Or you can also set and get the items individually. So you can call set image for segment at index. Obviously, the leftmost index is 0. And then at any time, you can find out which item is selected by looking at the selected segment index. And it's a control, so you set target action to find out when it changes. Okay, just like a button sends you action message, right, to the target. When it changes, same thing here. Every time someone clicks on this thing, it's going to send target action. You ask back, what's the selected segment index? You can find out what they've selected and respond to it. There's 3 different styles up there. The first 2 are very similar. One's the plain style, and the second one's the border style. You can maybe see the difference. It's just a slight border around it. The third style is important. That's the style you use if you're going to put one of these things in like a navigation bar. Okay, and if we get to the demo, I'll show you how to put it in a navigation bar as the center, kind of the center of the navigation bar. Okay, which is a pretty common thing to do. All right, so that's segmented control. The next thing I'm going to talk about is alerts. So you've seen probably both of these alerts as you've used iPhone applications. The one that we call alerts really is the thing that puts up kind of a translucent window right in the middle of the screen usually that says network error, continue, cancel, or yes or no or whatever. So it's that kind of alert. And then an action sheet is usually, here's 3 or 4 choices you can make right now for how to continue in this application. They're usually not, action sheets are not usually for emergency situations. They're more for branching decisions. Okay, so I've gotten to a certain state in my user interface. The user is asking for something. I need some piece of information from the user to branch off in a certain way. Set, in the demo I'm going to do set a color, or go to a certain one screen versus another screen, maybe delete a file or choose another thing or something like that. So action sheets, more of a branching thing. Alerts are more notification something has happened. Alerts often happen asynchronously. So you're wandering along using your app, all of a sudden, oh, alert comes up. Something happened, okay? You had an error in the network, or you've got a new message or something like that. I would be careful with alerts. Alerts are very disruptive. right? You come up and whatever the user was doing, they're going to forget what they were doing now because they have to attend this alert. So use alerts sparingly. All right. Action sheets, on the other hand, are something where the user is going to expect it to come up because they're going to do something that's going to require a branching decision. So here's what they look like. There's an action sheet on the left and a typical alert on the right. Okay. The action sheet on the left, you can see it's got a red button, self-destruct. That's called the destructive button or something like that. What do they call that thing? And then it's got the black button, that's the cancel button, and then the gray buttons, or the light gray buttons, those are the other buttons. Okay, so when you see the API, that's what we're talking about. Destructive button, the cancel button, and the other buttons. The alert only has a cancel button and other button. Okay, so cancel button is ignore, and the other button there is try again. All right, so here's what it looks like to create an action sheet. Its designated initializer, and the only initializer it has, is init with title, delegate, cancel button, destructive button, and other buttons. Okay, so you basically specify everything you need for that action sheet to be put on screen, including the delegate. Okay, you see that UI action sheet delegate, which is the object that's going to get called back when people click on that thing. All right, the titles are always strings. You can't have an action sheet with images in those buttons. And you can see that the cancel and destruct buttons, self-destruct button, are handled specially in the API. The last thing, other button titles, notice the comma ... there. I don't know if we've seen that kind of API. That just means you've used that kind of API, I know, like in NS Dictionary stuff. That just means you can list as many objects as you want here and end with nil. Right? So it's like a nil terminated list. Of NS strings in that case. You can create the thing using that and then also add yet more buttons programmatically, because sometimes you might be adding the other buttons, especially out of a dictionary, an array, or they're coming from some data structure, and so listing them comma separated there in the init doesn't really make much sense. So you could just pass nil as the other button titles and then call this repeatedly. You put the action sheet up using one of these show methods that you send to the action sheet. So there's show in view, which basically means this view that I'm passing as an argument is the thing that is causing this action sheet to appear. Okay, and we'll talk about what that means and why it needs to know that. You can also show from rect. So back to our example with the popovers. Remember, you've got some text in there and you select a word. You might do something in the UI that puts up an action sheet to make a decision about what you want to do with that word. Look it up in the dictionary, put it in the pasteboard, whatever. And then there's also show from bar button item. Okay, so you're on the iPad likely, and you've got a bar at the top, and you've got some buttons. You click on a button that wants to put up an action sheet to make some decision about what to do as a result of that button. So the show in view is kind of the generic one. And that one is one that's used on the iPhone usually. And what it does is it slides up from the bottom. If you remember that previous slide, that one slid up from the bottom, kind of covered the whole screen, right? On the iPad, you don't want that. Okay, you don't want something sliding up, gigantic thing sliding up from the bottom, covering this huge iPad screen with gigantic destruct button. That's really not what you want. Okay, you want it coming up in a little popover or something. Okay, and if you use show from rect or show from bar button item, it will come up in a little popover because you're giving it enough information to know where the popover should point. All right. Sorry. So the last two are ones you want to use on the iPad. You could also use them on the iPhone, and they would do the right thing on the iPhone, which is they slide up from the bottom. That's pretty much all that happens. But this is a case where you might have some platform-specific code here, right, where you're checking to see, because you'll know usually by whether you're bringing it up from the bar button or from a rect. It's like, oh, yeah, I'm probably on the iPad. So you probably have something else that tells you you're on an iPad that decides which one of these you call. So anyway, you show it, you call show, and then what happens is the user will click on something, and this message will get sent to the delegate, the UI action sheet delegate, which you had to specify in the initializer. And it's just action sheet, clicked button, add index. There's a few other delegate methods. You can look them up. One is dismissed with index, etc. Remember that the initializer had cancel button and destructive button index specially called out, and here's how you get those. You ask the action sheet for these properties. Usually you're doing that in your delegate when you get the message above, because you're getting an index there. You see that in this integer index, and you want to compare that index against the cancel button index to see did the user cancel, or compare it against the destructive button before you do something destructive. Destructive, by the way, means you're going to delete something, you're going to do something that's destructive. And you can pass nil, you don't have to have a destructive choice in there, but it just makes it red so that the user knows, hey, watch out, you're going to delete this. And part of the reason for that is the user interface guidelines say that if you're going to delete something, the user clicks on something, hits something that brings up an action sheet. If they hit delete at that point, you shouldn't bring up another alert that says, are you sure you want to do this? Instead, you use the destructive button. It's red. That's supposed to be enough of an alert to the user that, hey, you're doing something destructive here. Other indexes you can get the index of the first other button. You can get the total number of buttons. And you can find out the button title at a certain index as well. And you might compare that against some other data structure you have if you loaded this thing up using the add button thing. And you can programmatically dismiss the action sheet as well. When the user clicks on something, that dismisses the sheet. But you can do it programmatically with this dismiss. One thing to think about with multitasking is if you have an action sheet up and your app goes into the background, you probably want that sheet to go back down, because you're not likely to want to have that app come back in the foreground and be asking this question, because they're not even going to remember what they clicked on to cause this action sheet to come up most of the time. So there's an NS notification that you can sign up for that will tell you when your app goes into the background, and then you should probably dismiss this, probably by pressing cancel. So you could say dismiss with clicked button index, cancel button index, okay, to cancel it. Okay, UI alert view, very, very similar to UI action view in terms of its API. You can see it has a init with title. Notice it has a different argument there, message, which is the message along the top of the alert. It also has no destructive button. Okay, but it does have a cancel button, and it does have other button titles. You can have multiple buttons in an alert. Generally not recommended. It's also recommended that the title of an alert be short, that you don't have a big long, I tried to do a Flickr fetch and it failed because of the following HTTP request there. No, network failure or Flickr fetch failed. That's the kind of title you want, or the message you want to put in the top of things. You can add more buttons programmatically, just like Action Sheet. You display it by saying show. There's no show in view, show from bar button, any of that. You just say show, shows up in the middle of the screen, even on the iPad, dims the rest of the UI so it's not clickable. And the rest of the mechanism's the same. Delegate method, same delegate methods, all the same. Okay, timer. Any questions about the alerts? Okay, timer. So the timer is an object that allows you to set things up to send a message to an object. Okay, you get to specify what message it is. It has to be of a certain form, which I'll show you in a second. And it sends it to the object either once after a certain time interval, or repeatedly every time interval. So if that time interval is 1 second, every second it would send that message to the object. So the message has to take one argument. So here's the message is do something, colon. The one argument it's going to take is this timer. All right? So when you set up a timer, it's going to call your method with itself as the argument. Okay, repeatedly, if you say repeats yes at the bottom there. Okay? Couldn't be simpler. Very, very straightforward. Notice, though, before I talk about the real-time nature of it, it returns the timer too. The scheduled timer with time interval, it actually schedules the timer, and it starts running right away. And it returns the timer, but you don't have to send a message to the timer like start. It just starts instantly. It starts after the first time interval. It'll just start running, okay? The reason you want the timer back, though, is sometime in the future, you might want to stop that timer. Okay, and then you'll need a pointer to the timer because you're going to send it the message invalidate. Invalidate is kind of a wonky method. It does what you would think, and then it invalidates the timer and it stops running, but it also releases the timer. Okay? So it's a very odd method in that it releases, like release, but it also invalidates the timer, stops it running. So be careful of invalidate. Okay, I'm getting ahead of myself here. Not real time. It's not real time because this is working by just posting that message call onto the queue, the run loop queue for that thread, okay? And in the main thread here. So it may take it a while to get it back around to running it. You see what I mean? You might be doing something in your main queue that's taking some time, and it comes back around, and oh, it took 387 milliseconds instead of 250 milliseconds, which is what you asked for. So it won't necessarily be running exactly at the rate you want. Question?
How would you get a method to run at a specific time of the day? So say if you want to make an alarm.
Yeah. Okay. So the question is, how would I make it so that I can have a method basically run at a certain time of the day? And really the way you want to do that is with something I don't think we're going to get to. A lot of you are doing it on your project, which is great, which is local notification. Okay? And a local notification is a way that you say, I want this method basically to run at this time of day. But what's interesting about it is it'll run even if your app is not running. Okay? It'll launch your app and start it running to handle this this thing. So that's probably what you want if you want it to run at a certain times of days, and it's local notification. Yeah, so don't do anything too time consuming in this method because it's running in the main thread. You could fork off another thread to go do something time consuming if you wanted. Check the documentation for more. Really, I should have put up here the one more method, which is invalidate. That's the method that you need to stop the timer from running if it's a repeating timer. And in the demo, I'll show that. Okay, and lastly here, I'm going to talk about something kind of akin to NSTimer called delayed perform. So the method is perform selector with object after delay. Okay, this performs the given selector that you provide with the with object as its argument, and it performs it after a certain delay in the current thread. Not in the main thread, in the current thread. Okay? Why is this interesting? Well, it's interesting because there's also this method. Cancel previous perform requests with target, selector, and object, which lets you cancel something that you have said you wanted to do. So you say that you want to perform a selector in the future, like a second from now, and then a few milliseconds later you decide, oh, I don't want to do that. Then you call this cancel thing. All right? And so what would that be useful for? Well, let's say you're making a whole bunch of changes to a core data database, and you don't want to be constantly calling save on that thing, because we know that save is not free. But you do want to save it so that it doesn't sit there unsaved or the user might quit or something. So you have this, instead of calling save, maybe you call this method on your own object called delayed save, which passes the context. And what it does is it cancels any previous requests to do a save, and then it performs selector do save after delay 1 second. All right? So it's basically constantly re-queuing 1 second from now, I want to do a save. So as long as eventually you stop doing changes to that context for 1 second, then it'll actually do the save. Okay? So you would do this in an environment where you've got a lot of changes happening, and you know that eventually it's going to settle down and stop, and be back to user input, and you just want to do one save at the end. Does everyone see how this example would be valuable to have this perform and cancel thing? And I'm going to do a different thing in the demo, which is another good reason to do it. So hopefully with 2 examples of why you would want this perform after delay, you could see it. I'll actually talk about a 3rd example here. I don't have it on the slide, but sometimes you're in a situation in the main thread where you want to do something in the UI, but you really can't do it right now. Okay, because you're in the middle of something else, like you're in a table view or you're updating the cell or something, and you want to cause this cell, maybe this cell, to get updated, and you don't want to enter an infinite loop, and you don't want to really fork off another thread to do it. Well, you can just do perform after delay, a couple of milliseconds. It's going to get posted onto the run queue. It lets everything unwind, go back around the run queue, and then run it. You see? So perform after delay can also be useful for that, just postponing something, even just a few milliseconds in the future. And since this works by posting on the queue whatever current queue you're in, posting into its run loop, you can be assured you'll finish up what you're in now, whatever your method you're in now, and it'll go back around the run loop and then go run it. Okay? All right, so that's all I was going to cover today because I have demos of all this stuff. And I won't get to all the demos because we have 15 minutes left, but I'll get to some of it. Let's start with, let's see, what's probably the easiest one to do here? Let's do that NS timer first, the demo here. So that's in Label Mover. So let's go back to Label Mover. So what I'm going to do with my timer here is I'm going to have my label go into marquee mode. Does everyone know what a marquee is? That's where like the letters are scrolling by, kind of scrolling letters. So I'm just going to have my label, whatever it is, scroll. It's just going to kind of scroll around in an infinite loop. So I'm going to have a timer that does that. So here's how I'm going to do that. Sure, remember how to do it. So first thing I'm going to do here is add a instance variable here for my timer into my label mover controller here. I'm going to call it marquee timer. Sorry. And so basically when the view appears, I'm going to start this timer going, and when it disappears, I'm going to stop the timer. So in view did appear, I'm just going to say marquee timer. Actually, I'm going to be a little safer than that. I'm going to say if we don't have a marquee timer already, then marquee timer equals NS timer, schedule timer with time interval. We'll have the marquee tick, what did I say here? 0.35 seconds, so 350 milliseconds per tick. I don't want this one. So target is going to be self, action is going to be selector, do marquee, let's call it, and repeats yes. Okay, so I'm going to have this thing repeat. Other thing I need to do here is retain this, I think. Actually, maybe not, but I'm going to put a retain in here just to be safe. We'll release it down in our dealloc. The reason I'm kind of hesitating, don't remember 100% whether that's required, because when you schedule the timer, it starts running. It's obviously retained somewhere, but I'm going to retain and release it explicitly to make sure. I know when I invalidate it, it's going to get released, and I think that's the release. That release happens from kind of automatic retention. So anyway, pardon my not remembering exact memory of the memory allocation there. So that's it. So that's the way I start the timer. When the view disappears, I'm going to stop the timer. So I'm going to say marquee timer invalidate. I'm also going to set my marquee timer here to nil, because when, and actually, yeah, we definitely don't want to retain this, sorry about that. We do not want to retain that. And we do not want to do it here. I do recall now. Yeah, so when we create that schedule timer, it's going to be retained by the system, obviously, because it's running. And then when we invalidate it here and view did disappear, then it's going to get released. And I'm going to set it to nil here because I don't want to have a pointer to a released object. Okay? And so I know this is weird that invalidate is doing a release. There's almost no other place where that happens, where you call a method and it releases something. But this is kind of a special case because the timer gets forked off and it runs in the background like that. It's kind of strange. Anyway, so do marquee, we have to implement that. So let's do that. Void do marquee. And it takes NS timer, I told you, as an argument. And, sorry. So I'm just going to do this marquee thing. It's actually really easy to do. I'm just going to say my label.text equals ns string with format. What did I say? Oh yeah, %c. So I'm going to do a string and a character. The string is going to be the current label text substring from index 1. And the character is going to be my label.text character at index 0. Okay, now this would actually, let's fix it. If my label dot text dot length is greater than 1. Okay, because we need at least 2 characters to do this marquee, and I don't want to crash if I were to type a 1-character thing. Okay? Okay, so what did I type wrong here? Scheduled timer with time interval, target. Oh, sorry. There's one other argument that goes to this, which is user info, which you can pass along. And when I get this timer, the timer object has a method which will give me that user info back. So that's a way I can like pass some context, which I don't need to do here. Still didn't type it right. Oh, it says probably selector. Yeah, there we go. All right, so let's try this. Oh, whoops. Let's try this simulator. Okay, so you can see that it's marqueing here. It's kind of scrolling the letter around. And this will continue to work even as I'm doing my other things, or even if I go here, CS193P, because this timer is just kind of happening in the background. Okay? Everybody cool with that? Questions about that? Okay, I'm going to do the perform cancel previous thing. Let me show you how that, what was the example I had there, and remind myself. Oh, yes. So let's say our little label thing, we click and it moves. Let's say we wait a while and we don't click. Let's have it auto-click for us. Okay, so we're going to make sure that thing gets moved at least once every 6 seconds or so. And I'm going to do that by performing after delay 6 seconds, a kind of an auto move of that thing. But every time it actually gets moved, I'm going to cancel the previous one and put a new one on there. Okay, so that it doesn't happen every 6 seconds. It happens 6 seconds from the last time one happened. Okay. So how do we do that? Well, first of all, we got to think about when we're going to start this timer. And what I'm going to do is in my animation, you see here's my animation where I do the move. As soon as the move completes, I'm going to start this timer. Okay? So I'm going to put it in my completion. You see this is my completion handler of my animation, the moving animation. So you'll remember that it has this thing bool finished. And so I'm just going to say right here, self perform selector, I'm going to call it auto move with object, the label, after delay. And like I said, I could do 6 seconds, I could do 10 seconds, but to save time, we'll do 6 seconds. So that's all I need to do there, although I'm only going to do that if the thing finishes. Okay, so I'm going to do this when the last animation of moving finishes, because if I'm clicking and clicking and clicking and clicking and interrupting the previous ones, I don't want it to be constantly posting new perform after delays. And then there's the cancel part of it. So when am I going to cancel one of these things? And the answer is every time someone moves it, I'm going to immediately cancel it. So I'm just going to go here, NSObject. Notice this is an NSObject class method, which is kind of interesting. Cancel previous requests with target self. Selector, is that what it is? Yeah, selector. And selector, auto move. And object is label. Okay, so every time this label gets moved, I'm going to cancel that selector. Notice if I had move label moving multiple labels, this would still work. Okay, because the cancel would only cancel the one where this label is the argument. So now let's do the move, the auto move. Auto move, and it takes the UI label as the argument. And so I'm going to do that this way. I'm going to move it to a random place. CG point p.x equals, let's see, how did I have to do this? Oh yes, random mod int of my size.width and p.y equals random. Random generates a huge integer, and then I'm just using mod to modulo it. Bounds.size.height. Notice it's going to automatically convert. The result of that mod is going to be an int or even a long, and it's going to automatically convert it to a float. I don't need to explicitly do that, which is nice. And then I'm just going to say self-move label, label to point P, which is going to move it. It's also going to have the side effect of reposting this thing to happen again in another 6 seconds, which is kind of a nice feature. So let's see that happen. All right, so here I'm clicking on it. It's moving around, so let's see. 1, 2, 3, 4, 5, 6. There it is. I typed it. Let's go fast. Okay, so automatically moving. Everyone got that? Perform after delay, how that's happening? All right. Okay, so I'm going to let you vote on which one you want to see here. Do you want to see segmented control, or do you want to see action sheet? So raise your hand if you want to see segmented control. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and raise your hand if you want to see segmented, did I say segmented control? Action sheet. Action sheet 1, close, 2, 3, 4, 5, 6. I think segmented control is the winner. Okay, so we're going to do segmented control. I almost asked you twice for the same one, didn't I? Okay, so I'm going to do the segmented control back in Shutterbug, and what I'm going to do is in the map view, I'm going to have a segmented control at the top that controls whether I'm showing street view, satellite view, or hybrid view. Okay? So how do we do that? All right, well here we are in toggle map, and actually this is a good opportunity for me once again to show you that when you have an animation like this in toggle map, the changes happen immediately. Okay, they happen immediately inside of the animation. They don't happen over the course of the animation or at the end. They happen immediately. So if I wanted to I'm going to put this segmented control in my navigation bar only if the map view is not hidden. So I'm going to say if not self.mapView.is hidden. Okay, so if the map view is not hidden, if it's on screen, then I'm going to say self.navigationItem.titleView. Now the title view is a property on the navigation item that is the view that shows up in the middle of your navigation bar. Okay, you've already seen we have right bar button item and stuff. This is like middle bar thing, but it's a view. Okay, it can be any view. In this case, I'm going to set it to be a segmented control. So I'm going to have a method called, what did I call it? Segmented control or something. Let me get my cheat sheet up here so I don't waste your time. Yeah, here. I called it map type segmented control. Okay? And if it's not, then I'm going to say navigation item.titleView equals nil. Now when you set the title view to nil, it goes back to showing the title. Right? So if you say view.title, it goes back to showing that. So notice here that I've said if it's not hidden, that only works if this flip has already happened, right? Because the map view has to have been unhidden so that when I say if it's not hidden. But I just want to put this, I'm putting this code intentionally here in this way after this transition so that you understand that at this point, if the map view is not hidden by that transition, it's already not hidden. We don't have to wait for the animation to finish for it to be called unhidden. All right, so we have to implement this method map type segmented control. So let's do that. It returns a UI segmented control. How about paste? There we go. Okay, so I'm going to do this in a way that's kind of, I think, good for localization, which we haven't talked about, and for just general coding practice, which is I'm going to create a little static, which this could be an instance variable, but I'm going to make it a static. I'm going to call it, it's an NS array. I'm going to call this map type choices. Starts out nil. And so the map type choices are going to be the 3 words in my 3-part segmented control for the hybrid, the satellite, and the regular. So if the map type choices is not set yet, then the map type choices is simply an NS array. Oops. Array with objects. I probably should do alloc init, but we'll do it this way. In fact, is there an alloc init with objects? Alloc init with objects? No, there isn't one. Okay, well, then we will use retain. So here's array with objects. And I'm just going to put the types in here, and I'm actually going to make those also be constants. So I'm going to say map satellite. Well, actually, let's do it in order. It doesn't matter. Let's do map satellite, map hybrid, map standard. Nil. Okay, so that's just going to be array. They're going to retain this. So let's put those real quick. Pound sign define, map satellite. I'm going to have the word satellite. So these are the words that are going to appear in my control. Map hybrid. We'll call it hybrid. And just to show that it doesn't really matter what we say relative to the constant name, we'll call this one, map standard, we'll say normal. Now the reason I put these in a separate list like that and put them in array is because I might want to localize them. Okay, these words might be different in different languages. Okay, and by putting them in array, I can make it so those can be changed. Also, I could change the order here, and things will still work. And you'll see why. So now we just create the segmented control. UI segmented control alloc init with items. We're just going to use these items, these map type choices. Then I'm going to set this style, which is the bar, because I'm going to put this in my navigation bar. So that's segmented control style bar. Then I'm going to add the target action of myself. Add target self and action selector change map type, I'm going to call it. So that's the method that's going to get called when the thing changes. And there's also this other event we've never, I don't think, set target action in code, but there's this other argument for control events. And it's just a list of different kinds of events like touch down, touch up, etc. Common one to want is the one we want here, which is control event value change. So that's when the value of this changes. That's when the target action is going to be sent. Then I'm just going to switch on the current map type of this map view. And if it's the map type hybrid, then the segmented control selected segment index equals map type choices index of object map type map hybrid break. Okay, so you see here's where I'm looking the thing up in the array, and if it were changed or what, no matter what happens to the string, this code is still going to work because I'm matching up like satellite with this constant satellite. And same thing here, standard with standard. So even if I change the order or whatever, it's still going to work. And that's it. And so now I can return this segmented control. I'm going to return it auto-released because I want to be a good memory management citizen. And this method does not, this method, map type segment control, doesn't start with alloc or have copy or whatever in it. So that's good. And so now I just have to do the void change map type. Takes the UI segmented control. This is just a target action method. And all I'm going to do here is if the segmented control index is the index of map standard, let's say, then self.map. Somebody, did I type something wrong or something? Oh, good call. Good job. Map type equals mk map type standard. Okay, and we'll copy and paste to make this go faster. Copy, paste, paste, paste. Else. And this is, let's make this one be hybrid. So let's make this hybrid, and we're going to make this satellite, and so we'll make this one satellite. Okay. Okay, so that is it. All right. So everyone understand what we did here? We created the segmented control. This is its target action method right here. we're just saying if the map is not hidden, then we're going to set that segmented control as our title view. Otherwise, we'll set it to nil. So let's see if this works. Okay, so it's starting out good because we're in list mode here and there's no segmented control at the top, which is good because we don't want any of that in that case. Click map. Now we get our segmented control. Notice it's automatically updated it to the correct one, which is normal, right? This is normal mode, even though that wasn't the first one because of the code we had in there. This is all still working over here. And if we click these, then it changes. There's satellite. Here's hybrid. You can see it's got boundaries in addition to the satellite. This is satellite only. If we zoom in, up, we'll get the nice fast internet happening here. And if we switch back, then we'll be good. Okay? So there's your segmented control. The only thing I didn't get to show you was, what didn't I get to show you? What was it I said? I forgot even. What? Oh, the action sheet. So I'll tell you what, I'll put the action sheet in and post that code and you can look at it. All I do for the action sheet one is when you click on the label, you know, the label mover, if you click on the label itself, it'll put up an action sheet that lets you change the color. Now for like 3 different colors, cancel, and then the destruct button is reset the color back to black. Okay, so I'll post that. On Thursday, I'm going to try and cover some more stuff that you guys want to do on your final project. For example, I think I'm going to do the camera, because I know a lot of you wanted to capture an image with the camera. And then I'm also probably going to do sound, because I know some of you want to play some sounds. Maybe even I'll do record sound if we have time as well. So that's, I haven't made that lecture up yet, so I'm not quite sure, but that's what I'm thinking. So we'll see you on Thursday. Sorry to run over.
For more, please visit us at stanford.edu.